Hello, hello. Oh, there we go. Um, all right. I think we should be good today. The lights in the front of the room will choose what I think. Let's see what's suggested. Around. All right, so we're gonna take a look. We're gonna start looking at what are called measures of central tendency. But basically, so at the uh, video, I was talking about at the end, you know, and what we want to move to now is I've been asking you these questions, about the data. What's the spread of the data? What's what, what's the amount that you're or what yeah what's the most likely result you're going to get from this. And like I was saying, we've been able to sort of hedge and say, oh, it seems like this, it looks like this, it could be this. Now we want to develop the ability to really nail that down. What is the most likely thing that you would get from this data, or basically what is the average? What is the spread of the data? Because it's not just about the average. Like you guys have seen with the um, data we've been looking at, once you visualize the data, that data is actually spread out, and that's important. Results easily don't have to be in the middle, or not just don't have to be, are not going to be in the middle. They're going to be somewhere spread. They could be either in the middle or somewhere spread out around the middle. But we want to be able to have definite ways that we can identify the middle of the data, the spread of the data. So that's what chapter 3 is really about. So here actually get to define some ways that we're going to do that. And we'll especially see as we go. I want to talk about. Okay, so we'll define some ways to nail that down. What is the middle? For instance, today, like I said, they call it measures of central tendency. So the key word there is central. Really, what they're trying to look for is what is the middle of the data, or what is the most likely thing, most likely result that you would get from this data. What's the average? That's what the term that you've been using since like sixth grade or something like that. But what is the middle of the data? So we're gonna look actually not just at one way to do it. You would figure that we would just have one way to do it, teach you how to do it, case closed, lock the door, you're good. You know how to find the middle of the data. The surprising thing is we don't just have one way, we have four ways. Why do we have four ways? We have four ways because surprisingly, one way of finding middle of the data so isn't always the best way. So again, this comes back to the same issue that I keep telling you guys about, that again, in algebra, there is one right answer and maybe many ways to that answer, but there is one right answer. Done and done and done. Everybody's going to get the same answer. Statistics is a bit more subjective. So one of the subjective things, surprisingly, is that if you're looking for where the middle of a data set of a data set is this distribution of data that you get. There's, like I said, we have four ways to measure it because every one of those ways sometimes is a good lead on the middle of the data, and sometimes actually it's not the best. So one of those four ways is always basically your answer. It's the middle of the data, but not every one of those works every time, or like basically works every time is sort of the middle of the data. Um, So one of the things we wanna talk about as we go through finding kind of the middle of some data set, is then why? Why? So when we're gonna for a data set, we're gonna get some data. We're gonna find all four of the middles, and then we're gonna go through and look at which one is the best middle, basically, which one accurately describes the distribution that you see, and also kind of talk about why you know one particular middle doesn't work for a certain set of data that you see, whereas it would work perfectly. It would be the best measure for another set of data. etc. So, but that's kind of the lead in. We're gonna, in this lecture, we're gonna look at how do you definitively accurately find the middle, or at least as accurate as we can, find the middle of data. Um, we're gonna look at 4 different ways to find it, and in every situation we kind of come across, we're gonna look at which one is better, basically, which one of those 4 ways actually is the most appropriate, um, reads middle of the data the best for the distribution you're looking at. Also, this lecture, I easily know right now, we're at least gonna split it into 2 parts. There's just a lot, in this section. It's not bad, it's not hard math. There's just a lot. Always seems to be 1 or 2 sections in each of these chapters that is not just, it's like they're not equal amounts of material or concepts. There's 1 or 2 sections that are just a lot of material in one. So this is one of those. So I'm at least gonna split this into two videos, possibly 3, but I really want to do it in 2. I don't want to drag it out to 3. So this will be part 1. This will be the first part of measures of central tendency. So basically, how do you find the middle? Let me go ahead and turn on this, some data up for us. Good stuff. Talk about the middle of the data. Choose with them. Can't. No. Hold on. Ah. There we go. Um, We're going to start with kind of a small data set. So we're going to start with number 7 here. So this data shows the number of paid days off workers get in a sample of various countries around the world. So we only end up with, in this sample, we end up with 9 countries. Obviously, there's plenty of other countries, like 200 and some odd countries or something like that. So they grabbed just a small sample out of those countries. This is the number of paid days off that workers get in a sample of those countries. Now, this is likely there's two ways they could have gone about this. They could have gone and sort of surveyed a bunch of companies in these different, businesses in these different countries and just, see how many paid days off, people were given and then did an average. So that's one possibility. More likely what they did, so most countries have at least some sort of government policy, right? So whether that's states or a federal government, that, that depends on the constitution for the country and how they kind of regulate those things. But there's some sort of law or regulation somewhere that says companies have to give a certain number of paid days off a year. And so that's likely what this data is coming from, is just looking at those laws, looking at how many days that a company has to give, as paid days off per year. So there's some country where, companies are on average giving 38 paid days off per year to their employees, another where there's 29, 10, 34, 28, 30, etc. All right, so like I said, the point of today and this set of lectures is we want to find the middle of this data. We want an idea of what's the average. So if this is 9 countries and this is, you can see already looking at the data that there's at least a little bit of variation. There's a decent bit of variation there. What is the average? What's the middle? What would I expect if I just picked one of these countries blindly? What would I expect to get for the average number, the average number of days that somebody gets paid days off? Like I said, there's actually 4 different ways you can find that. This may be the only, I think, what I want to do with this. Let me actually write this data off to the side, y'all. And this time, I need much more board space for this. So let me write this data off to the side. So 38, 29, 10, 34, 28, 30. Oh, 30, 26, a 19, 20, and a 25. So once I got that there. Camera back over. So these are the paid days off for these 9 countries, selected randomly. Assuming there are 4 different measures that we use for what is the middle, what is the average. And so let's go through how to calculate each of these. There is one called the mean. And the mean is, so again, from about 6th grade on, you guys have been taught to find the average of something. And the mean is probably what you were taught. So that word average, what you think of, again, like I said, what you did in 6th, 7th, 8th grade, when they said find the average, that's that little process that you did, that's what they're talking about here. So mean means that you add all of these numbers up and you divide by how many there are. So you basically treat each of these numbers. We'll talk about this or this way of vocab later, but you treat each of these numbers like they're weighted the same. Each of them is one bit of data, which they are. Add them all up and you divide by how many there are. When you do a mean, I was looking at, so every stats book has different rules basically for when you do a mean, should you round to, for instance, these are all whole numbers, right? These are all, so should you round to the nearest whole number? Should you round to 1 decimal place, etc. It's looking like for this book, they're gonna have you round to one decimal place for the mean. So for the mean, you add all these up and divide by how many there are. Very simple. And like I said, it's probably what you've, um, it's probably what you have been taught the word average means. So let me have you guys do that. This is a quick one, but take a pause on your side. I'll pause on my side, and go ahead and find the mean of that data. All right, easy enough. So first you have to add all these numbers up. And let's see, give me a second. That's gonna be 67, 77, 100, 39, 16, 90, 205, 125, 144, 64, 289. So to add all those up, again, the mean is add them all up. You divide by how many there are. So the add them all up part of this. Go. So the add them all up part, you should have got 289 when you added them all up. And then we're gonna divide by 9 there. Like I said, we're gonna round this to one decimal place. So that's the one thing that probably do that. But that's the advantage of a tool. So what I'm getting there is 32.1. The average days, oh, you know what? Sorry. As far as the rounding here, I'm sorry, guys. This book does like to emphasize one decimal place. However, the other thing that you should, not just they do, they often do, but you should do when you're finding, I'm sorry. The other thing you should do when you're finding something like this, a mean, you know, just all the stuff we're gonna look at is you also want to think about your data and like what your result means. So like, for instance, if I sit here and say that the mean is 32.1 days, is it possible to take 0.1 days off of your work? Not really, right? So the context that you're talking about actually affects how you do your rounding. Whatever, you know, so for the sake of your homework, if there is something there that says round to blah, 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 yes, round to blah, blah, blah. But in real life, so we want to, this is a tool that we want to use for, you know, for some classes we're going to do or some research we're going to do later or something like that. For the sake of real life, when you're me just one second, guys. I think let's see if there's a might be a class coming in. All right, I'm back. Good. Nobody needs to use my room. So it's not really my room, but I kind of think of it as mine. But anyways, so when you're getting, so real life, you're getting this data, and again, you're trying to communicate something of your results to people who are going to read it. It does need to follow the context. So real life, forget whatever rounding instructions you would get on a stupid homework, because that's all they are. It's just problems to get you to practice, right? Reality, no way to have 32.1 days off. There's a way to have 32 days off or 33 days off, but not 32.1. In reality, this would be rounded actually to the nearest whole number. So 32 days off. So the mean, add them all up, divide by how many there are, is 32 days. So we're saying the average country gives about 32 paid days off per year. What we're trying to say there. So this is one way of finding that average or that middle. But this is, like I said, this is not the only way. So you can also, let's see, let's look at. Look at, there is a second type of average or second way to find the middle called the median. And when you see the word median, a good word to kind of tag to this, the word middle. The median really is quite literally, we're going to look for the middle of this data. So I'm going to take this data, I'm actually going to reorganize it. I'm going to line this data up from least to greatest and physically, visually look for the middle. So the interesting thing about the median doesn't have a nice formula to calculate it. It's actually, in some sense, it's more of it's a visual procedure. Your goal is to find the middle of the data. Do that, you're going to need to list it from least to greatest, and then physically, visually find that middle. So system. The greatest. And find middle. That's what we need to do with this data. So that's actually what I'd like you to do then. So over here, just kind of wherever on your page, but over here, my goal, what I'm gonna do is I'm gonna take this data and list it from least to greatest, and then I want you to find the middle. And I want to get you guys to try this first because this is one of those, don't make it more complicated than it is. Don't let them fake you out. This is actually really easy. List from least to greatest, find the physical middle of that list. So go ahead and pause on your side. I'll pause on my side. See what you get there. All right, good. So looking at this data, the lowest number I see is a 10. So yeah, see all this. Then what's the next? So we have a 10. Looks like 19 is the next highest number. 20. There's a 25. There's a 26. There's a 28. There's a 29. 230s. Looks like one really high number, relatively high. Notice on each end, actually, we kind of have a number. We have a 10 here that's 9 away from the next lowest number. We have a 38 that's 8 away from the next highest number, right? So we kind of have these two, some oddball country that only is 10 paid days off per year. And then some incredibly generous country, probably Sweden or something like that, which gives 38 paid days off per year. And then, but then the other countries seem to fall in this interesting kind of range between about 19 and 30 days per year. You guys have ever, if you know anybody from Europe or ever been to Europe, and not that I don't know how many of these random picks was actually from a European country, but Europe has some pretty awesome laws that are built into actually the constitutions that they have for their countries. And about one of the pretty awesome laws is there, the way they look at it is constitution is for citizens, right? Not the business. So they have a bunch of regulations on businesses, making sure that what the businesses are doing are not adversely affecting, just basically not adversely affecting citizens. So one of those regulations is paid days off per year. So it is very typical in Europe. I got my PhD in Spain. It's very typical in Spain in August for a bunch of people to come down from Northern Europe and kind of hang out on the beaches, right? And you would figure, well, how in the hell can they do that? Because that's a lot of missed time, right? And when I say spend a lot of time, I mean like 4 weeks, actually. It's pretty common for people to come from Northern Europe down to Southern Europe and spend about 4 weeks. And vice versa. People in Southern Europe, when they want to take a vacation, they go to Northern Europe, you know, catch a bunch, go up to the Alps, catch a bunch of cool stuff there. Same thing. They spend, they often spend about 4 weeks off. And so figure like, how in the hell can they do that? That's, like, how do you go 4 weeks without getting a salary, right? Or without working so that you can get paid. So one of the regulations that they have in almost every European country is businesses have to give you, I think it's actually 6 weeks of paid vacation a year, paid. So the way they look at it is you've worked a bunch for this company, right? You're making that company go. The company, basically the two things that make a company successful is the vision of the founder and how they organize and put that together. But then all of that vision and organization doesn't mean anything if the people don't work and make it happen, right? And in general, unless it's a small farm or something like that, it's not people who put the company together that they don't even have enough energy and time, right, to make all this stuff in the company work. You need to hire employees. So the way they kind of look at it is it's kind of a 50-50 thing. So the employees got to work a ton to make this vision and this thing happen so that everybody can make money, so that people can get paid and they can live. And so the founder can make their money and get profit off of it. Anyways, so the way they look at it is you've been working a ton for this business then has to give you paid time off. It's not even an option. It's not even a question. It's if you're going to be a business in Spain, you have to pay for 6 weeks of vacation for your employees. Because by the way, they're the ones that's making your business make money and go, right? So that's kind of how that works in Europe, and not just Europe, and quite a few other countries. Not every country in the world. Even again, look at this distribution of data kind of from lowest to highest. There's obviously some that give a lot less. But in Europe in general, it's about 6 weeks, 6 weeks of paid vacation. So that's how everybody from Northern Europe spends 4 weeks in Spain, Italy, Greece, whatever. And again, it's paid vacation. So it's you've already worked and made the company go. They have to pay you while you're out on the beach. And vice versa. The people from Southern Europe that go up to the Alps and go up to all these nice places in call it in Northern Europe, companies that they work at have to have to continue to pay them while they're on vacation. So just so a little bit of not just maybe how that works somewhere else, but to know that that's actually decently typical in a lot of other countries in the world. It's the way they look at it is the Constitution is for the citizens, not the businesses. So the businesses have to follow certain laws to make sure that people are taken care of, essentially. So, anyways, so we have some outliers, but most of the countries seem to be 19 through 30. So you had to find the middle of this list. So this is lowest to highest. Let me make sure too. I feel like my count was off. Is this 10? Wait a second. No, I feel like did I write something down wrong? No, this should be never mind. It should be 11. Is this 11? 2, 3, 4, 5. Missing something, aren't I? It should be 11. Something was wrong. 8, 29, 10. 28, 30. 30. 6. 25. So what did I not copy down here? So we have a 10. 20. 25. 26. 28. 29. Oh, I missed the 34. Sorry, y'all. No, that's what it is. Oh, this was 34 and then 38, sorry. Then that top end is not so weird. I do have one weird country at the bottom end. Weird compared to everybody else at least, so. All right, so now you want the middle of this list, sorry. What did you guys find? Visually, where would the middle of this list be? Good, that's easy enough. So like literally when I say visually, I mean, and so in some sense, one way you can do this is just sort of count over, one way to do this is basically count from high, basically put a mark or put your fingers or whatever, your eyes, but just kind of mark the highest and the lowest and scratch those out and then keep doing that with the highest and the lowest till you hit a middle. Notice the middle here is going to be 28. Another way to think about it is 28 is the middle because you got 5 numbers above it, 5 numbers below it, so it's exactly in the middle of that list. And or you could just cross out 10 and 38, cross those out, and then 19 and 34, and then 20 and 30, and 25 and 30, and 26 and 29. That is the middle of my list. So my median here is 28. So if we use the median, then we would say the average country in this sample, or we'll say the average country in the world gives about 28 days of paid leave, which is 4 weeks, by the way. So notice that first thing to notice the mean and the median don't agree. So these, like I said, these 4 different measures of the middle rarely agree. So, like I'm not saying sometimes they do, but they actually rarely agree exactly. And as we do these problems, you might kind of see why. One, notice that they're completely different ways to sort of calculate and get at the middle. So they shouldn't agree just because they're different methods. But also they kind of do a different thing. So the means basically looks at this almost like these are like weights, right? So this is 38 pounds and 28 pounds and 10 pounds. And so we add them all up and divide by 9. That kind of finds sort of, well, yeah, I don't know. I know I keep reusing the same words that I don't want to reuse, but reusing the word average, it kind of gives you the average pounds. Whereas median really gives you the actual visual middle of that list of data. So I said there was 4 of these. The next one we're going to look at is mode. And a good word to think about with mode when you're trying to figure out the mode is most. So mode is a different idea, a different way of finding the middle. You're doing with mode is you're literally trying to figure out which number do you see the most, which number happens the most. So again, mode is then another one of these middles that there's no way to calculate this equation, like calculate what the mode is. You literally just have to look at your data set and count and figure out which one happens the most, which number happens the most. What do you guys see here? Either way, but it might be helpful when it's written out from least to greatest here. Which one happens the most? Good, 30. You can see it, it's immediate. Mode here is 30. So if we're going to use the mode to tell the middle, to tell the average, we would say that the average country gives 30 days of paid leave. And there's one more called the mid-range. Now the mid-range is kind of an interesting thing in general because so I've been teaching for 15 years in college, a year and a half in high school before that, and before about 5 years ago, mid-range was not in statistics textbooks. It was something that if you knew statistics, you kind of knew maybe something you could do, but it was not written in textbooks. I did not have my students find a mid-range at all. Again, I knew that it was a viable possibility for this thing, but we'll kind of see as we do mid-range and as you use it. Mid-range often is not the best measure of the middle. So it's a calculation and you can do it, but when we start looking at the distribution of this data, we start getting a picture of this data, you'll see that it really actually isn't the best play almost every time. Occasionally it's a good play, but almost every time it's not the best play. So I think they've added it to the statistics textbooks because in some sense they want to give you the full look at all the different ways that we normally find an average middle. But for the longest time, it wasn't in the textbooks because if you ask the statistician, why don't you use this? They'd be like, well, it's just not good most of the time. It's not a good play. Why would I put it in a textbook about good ways to find an average, right? So it's kind of an interesting thing. But I noticed about 5 years ago, they started putting it in the textbooks. So the last 2 times I've taught this class, I've had to teach my students how to find mid-range. And that's fine. So mid-range. So mid-range is a lot like, so in an algebra class, you may have had problems where you had 2 points and you had to find the midpoint of those. So midpoint is kind of a good way to think about what we're doing with mid-range. Because when you're doing algebra and you're finding the midpoint, so when you find, let's just talk about a midpoint. If I have 2 points here, I draw a line segment between them. The midpoint, the middle point, is literally the point that's halfway between them, but it's halfway between them in terms of distance, right? So it's not halfway between them as far as listing them out. It's literally just saying, you can almost think about it, this is your lowest, this is your highest, or this is your left and your right, and I want the point that's exactly in the middle, distance-wise, between those 2 points. So in an algebra class, you'd have some sort of coordinates for this. So maybe this is 1, 3, and that's, I don't know, 9, 6, something like that. Then I want to see if you guys kind of remember this. So if these were the coordinates for my 2 points, how would I go about finding the coordinates for the middle point? See if you guys remember. All right, so to find the coordinates for the middle point, what you might remember is actually what you end up doing is you essentially take your x values, the 1 and the 9, you add them and divide by 2. So finding distance-wise, finding the middle of two numbers is always the same. You add the numbers and divide by 2. So I take the 1 plus 9 and I divide that by 2. Then I take y values and do the same, 3 plus 6 divided by 2. So it's this calculation here that's, so you were taught this likely in an algebra class and then really never did it again, likely. This calculation though is classically, that is how you find the middle of something distance-wise. So it doesn't have to be an algebra class. You could use this particular idea, this calculation of you want the middle of two numbers, you add them and divide by 2. You could use that for a bunch of different things. You don't often see it in books anymore. So that particular calculation is how you find the middle of two numbers. And so for a midpoint in algebra, this little calculation is helpful. So 1 plus 9, by the way, is 10, and divided by 2 is a 5. 3 plus 6 is a 9. 9 divided by 2 is 4.5, or 9 halves. But that would be my midpoint then, 5, 4.5. So so what I'm saying then for statistics, mid-range is just midpoints, but for a data set. So then just like with midpoint, you need to basically be able to see the low end and the high end of your data. You need to be able to see the left and the right. So what is the low and what's the high on the data that I have here? Good. This is my lowest. This is my highest. So if I want the middle of those two, the mid-range, then I just add the two, divide by two. Same exact calculation. You're just doing it for a set of numbers rather than for points on a graph. For the mid-range, I am gonna take the lowest plus the highest, divide by two. Just find the middle, the lowest and the highest. So let me actually write that out in words. So you have something here that approximates notes. Lowest plus highest divided by two. So here that's 10 plus 38 divided by two. What would that give you? You guys a second to do that. That would give you 24. So the mean of this data is 32, median is 28, the mode is 30, the mid-range is 24. I will say in this section, a lot of your homework is they just ask you to calculate these things. So you can do that now. Notice this again. So like I was saying, they didn't include mid-range a lot for in statistics books for a long time. And I'm saying, and I'm telling you the reason for that is if you ask a statistician, they would say that most of the time it's really not a good measure of the middle. Notice how far the mid-range is off from these other numbers. So the mean, the median, and the mode, they're all sort of, they don't agree with each other, but they're at least close to each other, 28, 30, 32. The mid-range is all off by itself. So like I said, I mean, we'll probably see some situations where the mid-range is the best play, but you don't see them often. Just don't see them often. All right. So then the question is, so like I said, there's plenty of homework problems where you're just going to calculate these and then dust your hands off and go to the next problem. But then you're going to have some homework problems where they're going to try to get you to analyze which of these is the middle of the data, which of these is the best judge of the middle of the data, the average. So then the question is, how do you do that? Because again, I think the funky thing that you're getting here that you wouldn't expect is, again, in an algebra class, you have one answer. In a statistics class, if I ask you to find the average or the middle of the data, you now have 4 answers. And you got to pick which one fits the distribution the best. So how do we do that? The way we do that is we need to actually graph this data out. So everything that you did in chapter 2 about visualizing data, that now comes, not only comes back into play, but that's why we did it. So I need to get a distribution going of this data. And then based on that distribution, you'll see, so we'll get a picture out of it and it'll have some shape, probably one of those, I think it was like 8 shapes that we looked at, right? So maybe a bell, maybe it'll be a bell distribution, or maybe it'll be one of those J-type distributions, or a skewed distribution, or uniform, etc., bimodal. Based on what we see, we're then going to judge which one of these is a better, is a better look at the middle. But to do that, we need a distribution. We need a picture. So that's the next thing you want to do. And then, by the way, on exercise 7, as far as this section officially goes, I don't think they asked for this, but this is, again, I'm not teaching you guys the homework. I'm teaching you guys statistics. So this was the next thing we would do is we need to get a distribution going of this data. Then check which one fits the best. So if we're going to get a distribution going of this data, that means that probably going to have to turn this into a frequency table. So again, going off that last lecture, we looked at scatter plots, and scatter plots happen when you have sort of X and Y data, or you have kind of 2 bits of data that are connected to each other. We don't have this here. This is just this is just X's. This is just one set of data. So if you just have one set of data, then you're thinking, I need to make a frequency histogram out of this. I need to make basically a bar chart out of this. If this was something over time, we would maybe make a time series graph. If this is something where percentages mattered, we make a pie chart, etc. So um, I call it sorry, all those diagrams from chapter 2 now kind of come into play. So I need to get a visualization of this data. So the first thing you got to decide basically is what type of visualization are you going to use? Is it going to be a frequency histogram? Is it going to be a bar chart? Is it going to be a dot plot? Is it going to be a stem and leaf plot? Like, what are we going to do here? That all depends on the data that you're looking at. So I want to get you guys' thoughts. So this is again where there's not necessarily a right answer. There's probably about two different, I would say from what we looked at in chapter 2, my own mind, just as a really, just me thinking about it quickly, there's probably two different, um, probably two different, I can't think of words right now. I want to keep saying charts. There are two different types of graphs that would probably be the best play for this data that I see. So I want to see what you guys think. I want to see if you think of it. So take a second and think about what you did in chapter 2 and kind of shout at the screen, which type do you think is going to be the best? Which type of graph do you think is going to be the best for this distribution? And so let's look at the ones that definitely don't work, or let's kind of talk through the ones that definitely don't work. We definitely don't want to do a time series graph. There's nothing about time, nothing about things happening over time in this. And like I was saying with the pie chart, a pie chart is a nice idea, but there's no real, this is not about percentages. So that's not going to help us either. What that leaves us with is basically a bar graph or a histogram, stem and leaf plot, and a dot plot. I actually want to go backwards with those. So let's talk about the dot plot because we did the dot plot. That was one of the later things we did. And at least, I don't know, maybe it wasn't visually pleasing to you, but at least for me, I look at a dot plot. I really like dot plots. They're visually pleasing. Like we were talking about, they give you the effect of a bar graph. So it's easy to analyze visually, but they also give you a lot of detail. So I would always like to do a dot plot. And there's part of this that does set up well for a dot plot. It's basically, we can make a number line from 10 to 40. You just start marking out, by ones. But I think for this, the reason a dot plot wouldn't work well is don't have we don't have many of anything right here. So like we have 110, 119, 120, 125, 126. The only thing that has more than one is a 30. And those dot plots, if you think back to that example we did, they're really nice when you have some pretty tall bars or when you just have some variation, right? Some bars that are 1, some bars that are 2, some that are 8, some that are 5, etc. So visually you can get that contrast and you can see a shape and compare and contrast things. But you're not going to get that here because there's only one of almost everything here. So this is not a good candidate for a dot plot. But it's maybe a good candidate. It's definitely a good candidate for a histogram because I can, my range roughly is from 10 to 40. I can break 10 to 40 up into say 8, we talked about with histograms, you need to break it up into classes and we can break that up into what, 8 classes of roughly 4 each. And get some pretty decent play there. Or you could do a stem and leaf plot and just break this up into tens. So basically all my tens, my 20s, my 30s, etc. And we could get a pretty good diagram out of that. So I would say looking at this data, either a frequency histogram, a bar graph, or a stem and leaf plot are your good plays here. I want to make this easy on myself and do a stem and leaf plot. Give me a second. Am I really going to get anything much different with a bar chart? So if I did a bar chart, basically doing groups of 4. Yeah. Turn out much different. Yeah, I think we could go for either, and so I think I'm gonna do a stem and leaf plots, because honestly, it'll just take less time. Stems, these will be my leaves. My stems, I'm gonna count by tens, so this will be my tens, my 20s, my 30s. That's actually all we need for this. And then you're gonna list out the leaves. And again, a stem and leaf plot, basically when you turn it on its side, voila, you have a bar graph. Let's maybe do that. Yeah, no, let's do this. I'll stick with my decision. All right, so I'll have you guys pause on your side. I'll pause on my side. Go ahead and finish out the stem and leaf plot. And then start to look at the numbers, these four middles that we have, and basically tell me, start to think about or start to figure out which one you think is the best middle, kind of why. Just it doesn't, and that why doesn't have to be a crazy specific academic reason. I'm just saying, like again, you're the thinker, you're the problem solver here. So once you have the picture, you should figure out which one of those middles you think best fits it, and give your own reason why, just why you chose that. Go ahead, pause. All right. Let's see what you guys got. So as far as the stem and leaf plot, you'll have a 0 and a 9 here. And then in the 20s, we'll have a 0, a 5, 6, 8, a 9. Then my leaves will have a 0, a 0, a 4, and an 8. So that's sort of my stem and leaf plot. And again, in your head, if you turn this on this side, voila, you have bar graph, and that bar graph or the stem and leaf plot, what would you, so before we go to which one you think is the best, what would you say the distribution is? So again, those shapes of the distributions, what would you say the distribution is here? And again, there's probably a couple answers that you could argue. One of them is you could argue this is a bell shape. But I will say, notice that this right end is almost as high as the middle, or kind of what we're seeing visually is the middle class. And I say the right end, I really am imagining turning this over. The left end is really small, kind of compared to either of those. So I would say that this honestly looks a bit more like a skewed distribution, and it is skewed left because the low end is on the left. So this is a skewed left distribution. So then notice, so I'm gonna say right away, the 24 definitely would not be a good measure of the middle. It is in the tallest bar, the tallest class, but it's not even halfway up the tallest bar. And it doesn't even hit the second number in that tallest bar, right? So it's like a 24 just is way off. It's not the middle of this data. So the average country in the world is not giving 20, that's not a good report or not a good measurement. The average country is not giving 24 days of paid vacation. But then, like we said, these other three are kind of in the same area. So between these other three, what did you think? Which one fits the middle of this data the best? So notice that the mean is a 32, which puts the middle kind of, roughly in here. And even though this, I mean, this is a tall bar, but still that puts the mean kind of high in the distribution. And we know there's a lot more of the distribution. Most, quite literally, maybe not half, but most of my measurements are actually in the 20s. So that's a good hint that the mean is not a good measurement of the middle here. And it's because we have this skew. It's honestly because it kind of tails off on the left here. So essentially, if you think about even just the numbers that you added up, we were talking about how this 10 is, so for a mean, you add them all up and you divide by how many there are. But there's one number that was just a lot lower than everything else, right? There's this huge gap. So anytime when you're doing a mean, when you're adding them all up and dividing by how many there are, anytime you have one number, or a couple numbers that are really low or really high compared to the rest, it kind of pulls, the calculation that you get, the answer you get for the mean is going to be a little high or a little low compared to these other measurements that you're getting. So yeah, that 32 is just a little high. I wouldn't call that the mean of this data either, or the middle, sorry, the middle of this data. I wouldn't call that the average of this data. Most of this data is below 32. So the average country doesn't give 32 days off of paid leave per year either. So it looks like here the median and the mode are at least are in the final running as the better measurement. Between those two, what would y'all say? And you honestly could probably make an argument either way. So I think some statisticians would look at this and say 30 is right at the boundary of this highest class, right? So argue it's sort of basically in the 20s anyways. And there is two of them. There's the very real argument of out of all these countries, there are two countries that happen to give this same amount per year, and it's close to the visual middle of this data. So you can make an argument that the answer is the mode, which is 30. You could also make an argument though that the answer is the median because the median is kind of high up in this second bar where most of our data is. So visually 28 is literally looks like the middle of not only this list, but now it looks like the middle of this spread of data. It's not low in the 20s, but it's high in the 20s. Most of our data is high in the 20s or right at 30. So you can make, and it is quite literally the middle of the data if you list it from least to greatest. So you can make a strong argument that 28 is the real answer here. So I think out of these two, you could argue that 28 and 30, one of those is, both of those are good, but one of those is our best answer for the middle, the average of the data. Either 28 or 30 days. Like I said, there's kind of a strong argument both ways. Again, statistics, when you get to this part, there's still a bit of subjectiveness. So we now have 4 ways to calculate the middle, but often you'll find that 2 of them, you can make an argument both ways. But whichever ones you decide are going to be the right answer or that we say are the right answer, it's based on this picture. It has to match visually what you see is the middle of that picture. So the average country gives, I'm going to say 28 days. I think the median fits the middle visually just a little better here. But like I said, you can make a stronger argument that it's 30. So I wouldn't mark you off for that. I think there's an argument both ways. But the average country on Earth gives 28 paid days of leave. 30 if you want to make that argument. That would be the middle of my data, the average of my data. All right. So pretty much, yeah. So we need to do some more problems like this. So like I said, one of the interesting things about this is again, because the final analysis, which one is the average is really dependent on the picture, then here we got a skewed left distribution. If you get a different picture, a different distribution, then which one of these answers matches the middle is going to be different. Because pictures, the shape of that distribution is different. So those shapes of the distributions that you guys saw in chapter 2, it is really important that you visually memorize that. Find a way to visually memorize that because a lot of our analysis going forward is going to be based on those pictures. Those pictures then are actually really hugely central to which one of our calculations is going to be the answer in the final analysis type thing. So make sure you memorize those pictures. All right, so we'll go forward with more of them, but I think not on this copy. So I probably will turn this into 3 parts to this lecture. But this gets you started. I wanted to at least do this first part to really nail down what do we mean by mean, median, mode, and mid-range. So in the next part, we'll um, start with another problem, another set of data. And we'll find the mean, median, mode, and mid-range and start analyzing. We'll get the distribution going. We'll start analyzing which one is better. So we'll start there on the next video, and I'll see you guys then.